This is lesson 4.5, delocalization of electrons. So delocalization is when bonding electrons can spread themselves out among pi bonds, which makes the molecules more stable. So go ahead and draw a resonance structure or a Lewis dot structure for nitrate. You might have difficulty because there's three ways that you can draw it. Nitrate actually has all bonds equal. All bonds have a strength and bond length between a single and a double bond, because the three structures actually combine to form an average structure. So resonance is when the actual structure of a species is an average of the number of Lewis structures that can be drawn, or resonance structures. You might consider it like a horse and a donkey. If they were to have a baby, they would have a mule. So the mule is the average of the two structures. Here's another example. Benzene, which is shown down below, is actually very unreactive because it's so stable. If you look, the double bonds here, here, and here, you could actually draw them here, here, and here as well. And so the actual structure of benzene is an average of both of those. And so these pi bonds that are there above and below the ring in the double bonds actually allow the electrons to jump around the ring. And so through resonance, benzene is actually delocalized, meaning that the electrons spread themselves out through all of the carbon atoms and not just between a few. So delocalized electrons make molecules have intermediate bond lengths and strengths, and the bond order is equal to the number of shared electron pairs over the number of bonding positions. So just a single bond has a bond order of 1, a double bond a bond order of 2, and a triple bond a bond order of 3. But when you talk about things like nitrate, which has 4 bonds spread among 3 atoms, you have a bond length or a bond order of 1.33. Or if you think back to ozone, which had 3 bonds, a double and a single, divided by 2 oxygens, you have a bond order of 1.5. So the higher the bond order, the higher the electron density. Delocalized electrons provide for greater stability because the electrons are spread apart, which minimizes their repulsion. It takes more energy to disrupt delocalized bonds and react than it would to just interrupt non-delocalized or non-resonant structures. And the more stable the ion, the greater the probability of formation. So if a structure can form a delocalized structure, or a molecule can form a delocalized structure, it's going to happen because it's much more stable. Finally, delocalized electrons lead to electrical conductivity in metals and in graphite because the electrons can move, and so they can conduct electricity in the solid state.